Guys, today we're gonna watch a video of high voltage fuse made by Electroboom and react to it.
Think I'm getting PTSD. We all know what a fuse is. It's a piece of wire that melts open under high current and let's not get burned. And when it opens, when it burns, it cuts your circuit open, stopping the flow of high current and protects your circuit against fire and such. And every one of them has a different current rating depending on how much current your circuit normally needs and at what level you want them to blow open and protect your circuit. So these are short circuits with close to 0 volts across them. Then why the hell do they have voltage ratings? Like this is rated for 250 volts. It's still a
The voltage can easily jump a certain gap depending on the size of the fuse, and maybe that's why high voltage fuses are bigger and low voltage are small.
short circuit. It's not like if I place it on a circuit with a 2000 volt supply, there will be 2000 volts across this. In fact, let's try it with my high voltage transformer. These transformers are very dangerous and one of them has killed me once before and we don't want that to happen to anyone else. So don't. Here is a 10 ohm resistor as my circuit series with the fuse connected to the 2000 volt transformer, and so the fuse blows open quickly, protecting my circuit like this. Oh
Jump the gap.
Look at this. Even the glass cracked and broke under extreme heat. The voltage rating is not about the normal operating mode. It's for when the fuse breaks open and we want it to reliably open. We know a strong high voltage can jump the gap, creating an arc, keeping the circuit closed, like we saw. So in order to make sure a fuse or breaker actually opens, it needs to be made differently. Otherwise the arcs never die, and that's not safe. But you could be safer using my sponsor NordVPN. Psst, listen, NordVPN has a 30-day money-back guarantee, so you can start using it for a week on your travel while still having the opportunity to use their guarantee. Although I'm sure you'll like their service so much you'll keep using it. And NordVPN will protect you on so many different fronts. It's not just the data encryption service to protect your sensitive data and connection from your computer to their so many servers around the world. And access in shot using longer. We put 2 nails on a cardboard box. We put some very thin wire around the nails and we turn it on.
How to catch fire?
Fire! Oh!
Why is
No! In case of electric fire, never try to put it out with water. It creates shorts and can cause electrocution. Always try to cut electricity first if possible, then use non-conductive fire extinguishers made for this purpose. I guess this is why they use some sort of cover or glass for the fuse, so the molten metal and arcs don't start a fire. I have a plastic bottle. Let's try this one. We just put the nails and the wires inside the cup. Here's my fuse. Let's try it out. Here we are, and we turn it on. Oh
it melt the plastic. Yes, the same thing. It just melted the plastic where the nail was, and the nail came out, letting the arc go extinguish.
It took a while, but it opened, and the fire was contained in here, so safer? What if we vacuum in here so that there is no ionized air to help create arcs? Here I'm holding my super thin piece of wire here. Put it inside our vacuum chamber. Connect the vacuum pump. Now hopefully there is some good amount of vacuum and we turn the power on.
See it,
oh my god. Did you see that?
See.
Look at this nonsense. Oh my god! Oh, that was a failure. It's easier to create much longer arcs with much lower voltage in vacuum. I suspected that, but not that much. It's interesting because under normal atmospheric pressures, the 2000 volts can only start jumping under 1 millimeter gap. But as we saw, it jumps well over 10 centimeters in partial vacuum. This new transformer seems to be a little bit weaker than the old one I had, which I broke. I should get a stronger transformer. Me, not you, okay? You don't need to acquire anything that has a resemblance to this. Of course, after it starts, it can extend to a longer distance if the source is powerful enough. I suppose instead of a vacuum, you could replace the air inside the fuse container with some non-conductive noble gas like argon. Would that work? I don't have argon, so I'm thinking if I can make it happen reliably in air, it would be good. Like here, I'm taking a very long, thin wire, if you can see it, so that hopefully it can fall away quick, stopping the arc.
Yep.
It did work. I think I'm onto something. Maybe I can make it even quicker. Okay, hear me out. I'm running a very thin fuse wire between these two nails, and I have two elastic bands that are pulling this wire apart, keeping it at a tension in the middle. So when the fuse blows open, these elastic bands will pull the wires apart quickly and hopefully extinguish the arc as soon as possible. The fuse is shorting the 2000 volts, and now we shall turn it on. Oh, look, this is exactly how you expect a fuse to behave. Unlike the last time that the entire wire just evaporated, this time it just broke straight in the middle. The rest of the wire is intact and there was no huge arcs either. Awesome! So any mechanism that quickly breaks and pulls wires apart should be very good for high voltage. In fact, the microwave oven that I pulled the transformer out of has its own fuse. Where did I put it? I put my oven parts in my cookie box. Where is the fuse? Oh, there it is. Here's the fuse. It looks interesting, well protected in a plastic. Is it a box? Can I open it? Oh, look at it. There is a more regular looking fuse inside the plastic cover. It is a 5000 volts, 0.7 amps fuse. From my extensive experience with high voltage fuses, the gap doesn't look far enough to avoid big arcs. Let's try it out. But this is interesting. See the fuse.
Spring. So maybe from my guess, like it will melt the wire where the contact is, and the spring will just pull the wire apart super fast, so it will extinguish the arc. Or there's even some noble gas inside there that won't or high pressure maybe.
Fuse wire on one side is a spring pulled open, keeping the fuse wire under tension. So when the fuse breaks open, the spring pulls the contacts apart, eliminating the arc, like what I did with my elastic bands. Okay, the fuse now is shorting the 2000 volt output. Let's see if it works as advertised. Ooh.
Wow.
Well, I mean, the fuse wire is completely eradicated, including the spring and everything. Was there a point to the spring? But it's interesting. For such a small gap, there was almost no arc. Is there a special gas in there? I can't find anywhere if there is a special gas in these glass tube fuses. Somebody let me know. But in conclusion, that's why every fuse has a voltage rating. Use it outside the rated voltage and there will be death and destruction. So mind the ratings. Or else.
Okay guys, thank you for seeing the video. Please sure to subscribe, comment and share the video. Bye guys.